Welcome back, ladies and gentlemen, to some more free response questions. Today's contestant is the 2018 free response question from Calculus BC. This came from the calculator portion. It is your classic inflow-outflow calculator problem where people are entering into an escalator at a rate modeled by this piecewise function, this nasty thing from 0 to 300, and then people stop entering the line for the escalator after 300. R of t is measured in people per second, and t is measured in seconds. As people get on the escalator, people exit the escalator at a rate of 0.7 persons per second, and there are 20 people in line at time equals 0. First thing to note on your inflow-outflow problems is that this function here is a rate. It's already a rate. It's a derivative. So we got to make sure we keep that in mind. Next thing, we might want to put these into our calculator. So I have my trusty TI Inspire with me. And so here is function 1, the rate in from 0 to 300. And then the rate out, 0.7. It's a constant flat rate. So it should be hopefully a pretty straightforward problem. It says, how many people enter the line for the escalator between 0 to 300? Well, when I hear a question like this, I start thinking about the things that they don't care about. If I just want to know how many people enter the line, I don't care how many people were already there. And I also don't care about how many people left the line. So part A is relatively simple as long as you don't overthink it. Really, you just want to know how many people entered the line. So it's just integrating the rate of the people who enter the line. So that's going to be r of t dt. Now, I don't need to specify which version of r of t I'm integrating, because 0 to 300 implies that I'm using the top version. So if I enter that into the calculator, I'll go ahead and do this. I will get from 0 to 300 f1 of x dx. 270 people. 270 people have entered that line. 270 people. Okay, let's move on to part B. Part B, it says, during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line? Well, if I want to know how many people are in line for an escalator, there are three things that I need to consider. One, how many people were already there? And then I want to figure out how many people totally entered. And then I'm going to subtract the people who totally left. So what does that look like? Well, 20 is how many people we began with. They told me that in the problem. And I'm going to add that to an integral from 0 to 300 because they want me to find out how many people are in line from 0 to 300, or at time equals 300. So that's just going to be simply r of t, but then it's going to be minus 0.7, and that's all going to be dt. And after integrating all of that and getting all that stuff under our belt, that'll turn out to be 80 people. There are 80 people in line. In line at t equals 300. So, part C. For t being greater than 300, what is the first time that there are no people in the escalator? Well, remember, from time being greater than 300, luckily we caught a break because nobody's in line anymore. So really what we start off with is we start off with the people who were there at time equals 300. Well, how many people were there? Well, luckily in part B we already solved for that. There were 80 people in line right there. And because people leave at a constant rate, I can just go ahead and subtract the rate at which people leave times the number of minutes it takes for them to get out of there. And I know that that's going to end up becoming a 0 because that's going to become 0 people. So after solving for all of this stuff, you end up getting t being 114.285. Now, that is not 114.285 minutes, period. Remember, this equation is valid for t being greater than 300. So the actual time is really going to be 300 plus the 114.285, making it 414.285. So make sure you keep that in mind. The t being 114 something, that is not your answer. That's how many minutes beyond the 300 that you end up finding for there being 0 people in line. So overall, I think a pretty straightforward FRQ so far. Give me a second. I'm going to go and just delete this stuff here. If you need to, pause and then see if your answers compare. Leave any questions in the comments. And yeah, we'll take on part D. So it says, for 0 to 300, at what time t is the number of people in line a minimum? And we have to round it to the nearest whole number and justify the answer. Typical absolute minimum problem. So what I'm going to do is I'm going to find out one thing. I'm going to find out my candidates for an absolute min. Well, at minimum, it's going to be at t equals 0 and 300, because those endpoints are always candidates for an absolute min. Other candidates for an absolute min occur when the functions cross each other. So how do I find out what that is? Menu, analyze graph, intersection, lower bound, upper bound. Here's my first intersection. And then, again, lower bound, upper bound. So these two numbers. Now, if I'm a betting person, I'm thinking this right here, this 166.575 is a local max because my blue curve, which is the rate in, is above the rate out and then going below the rate out. You can justify that if you want to, or you can just find out what the value is. Honestly, I don't know which one's more work. So let's go and just write those down. I've dabbled in both versions of it, writing it, justifying why a local max is not necessary, or just including all the values. Again, I'm not convinced that one is more work than the other. So what I'm going to do is I'm going to make a table. And I'm going to say, all right, well, for t being 0, how many persons do I have? For t being the 33 number, so 33.013, how many persons are in line for the escalator? For the 166 number, 574, how many persons were in line? And then 300, how many persons were in line? Well, some of these we already know. This was 20. They told us that in the beginning of the problem. This is 80. We found that out in part B. Now it's got to figure out what these guys are. So this is t, and this is going to be number of people. So how do I figure this out? Well, this is exactly like B. I just got to find out how many people are in line at that moment in time. So from here, this is going to be 20 plus the integral from 0 to 33.013 of, looks like, r of t minus 0.7 dt. And that's going to get me something. And then this is going to be 20 plus the integral from 0 to 166.574 of the rate in minus the rate out. And those are going to get me numbers that look like this. Once you put it all in the calculator, you should get 3.803. And then this will become 158.070, making this guy your local minimum. So what you do is you then justify at the end. Your work serves as the justification, but the final fatality, if you will, if this was Mortal Kombat, then you would say the minimum number of people in line is 4 people when t equals 33.013 minutes. And I think that just about wraps it up for the escalator problem. Leave any comments or questions in the comments area, and I will see you guys next time. Stay healthy, stay indoors, and we'll talk soon. See ya.